question arises that which of these ball will hit the ground first. More precisely, this trajectory is So we'll start this video with a question. So here you see a person standing on a ladder and carrying two balls in his hands. Now he drops this ball straight down and the other ball in the horizontal direction like this. Now the question arises that which of these ball will hit the ground first. Let's see. So we see that both the ball reaches the ground at the same time, and the reason is that after dropping the ball, the only acceleration on the ball is acceleration due to gravity, which is downward. This is G, the direction of acceleration due to gravity. So both the ball fell at the same rate, so they reaches at the same time, but the difference is one ball traveled some distance in the horizontal direction and other ball doesn't travel horizontal distance. So this is the difference. Rest time taken by the ball is same. In the previous video we saw that the trajectory of a projectile is curved. More precisely, this trajectory is a parabolic path and I'm going to prove it mathematically. Now we obtained two equations. If you see the previous video, I took one example for the horizontal projectile and we obtained two equations. The first equation was x is equals to v0 times t and y equals to h minus 1 over 2 times g times t square. Now from this equation we can write that t is equals to x over v0 and I can put the value of t here. So this equation becomes y is equals to h minus 1 over 2 times g. Now t is x over v0 and its square. On further simplification, we'll get y equals to h minus g over 2 times v0 square multiplied with x square. Now this equation is of the form y is equals to a plus bx square, and comparing these two equations we can write that we have a equals to h and b is equals to minus g over 2 times v0 square, and this is the equation for the parabolic curve. Therefore this is the parabolic path, and thus we proved mathematically that this curve will be a parabolic curve. Now try to figure out from this figure where the projectile lands. So the projectile lands at this point where the y coordinate becomes 0 and we need to find this distance x. So how we can find this? We know that at this point the y coordinate becomes 0, so we can equate this y equals to 0. So let's do. So this is 0 is equals to h minus g over 2 times v0 square multiplied with x square, and on further simplification we'll get x is equals to v0 under root 2h divided by g, and we have considered the positive sign because we know that a projectile is launched along the positive x, so we'll get the answer to be positive. So that is why we have considered the positive sign of root, not the negative sign. Now you see that the video of the lava bomb is parabolic. Now let's take an example. Now here you see that a mountain climber encounters a crevasse and the opposite side of the crevasse is 2.74 meter lower. So this vertical distance h is 2.74 meter and the crevasse is separated horizontally by a distance of 4.10 meter. So this distance is 4.10 meter. Now there are two parts in this question that we need to solve. Now in the A part, we need to find the minimum speed needed by the climber to safely cross the crevasse. So he started running and he jumped with some initial velocity, let it be v naught. And in the A part, we need to find the minimum speed needed by the climber to safely cross the crevasse. So to solve this question, I'll be using the fundamental equation, which is the position as a function of time in x and y direction respectively. Okay, so in y direction we have y is equals to y naught plus v naught y times t plus 1 over 2 times ay times t square. Now when the climber is jumping, the climber is in free fall, and the only acceleration on the climber is acceleration due to gravity, which is in the downward direction. So we have ay equals to minus g, and ax, there is no acceleration in the horizontal direction, so ax is 0. Now this v naught is in the horizontal direction, so v naught is nothing but the initial velocity in the x direction, that is v naught x, and there is no component of this velocity in the vertical direction, so v naught y, this will be equals to 0. Now we can solve it further. So y naught is the initial position, which is h here, so we can put it as h plus v naught y is 0, so this whole term goes to 0. Now 1 over 2. Now ay is minus g here, so minus g times t square. Now y is the final position, which is here, and here y becomes 0. This also goes to 0, and on further solving we'll get time taken by the climber to reach on the other side of the mountain to be under root 2 times h over g. We can put the values. Under root 2 times h, we have 2.74, divided by g is 9.81 meter per second squared, and on further solving we'll get this 0.747 seconds. Now next, minimum speed. So for the minimum speed, what we can do is we can use the fundamental equation in the horizontal direction. So x is, it is a position as a function of time. X equals to x naught plus v naught x times t plus 1 over 2 ax times t square. Now there is no acceleration in the horizontal direction, so this whole term goes to 0. X naught is the initial position. Now at the initial position the x coordinate was 0, so this also goes to 0. Now x is the final position, which is 4.10 meter, so this is x as it is. V naught x, now v naught x is the initial speed, which is in the horizontal direction, which is v naught, so v naught times t. Now x we know and t we know, we can easily calculate v naught from here. So v naught, this will be x over t. X we have 4.10 meter, divided by t is 0.747 meter, sorry, second, and on solving this we'll get this value to be 5.49 meter per second. So this will be the answer for the A part. Now next, in the B part, it says if instead the climber's speed is 6.00 meter per second, where the climber lands. Now if the horizontal speed is increased, then this horizontal distance will also increase. He might travel somewhat here. Now we have to find this distance where it lands. Now one catch point is here, that the time it took to land here will remains the same, because no matter the horizontal velocity is increased, time is not a function of horizontal velocity. Time is 2 times h over g. There is no component or no value of v naught here. So if the v naught is increased, time will remain same. So we can use this equation to find our answer. X, this is the B part here. X will be v naught, we are given to be 6.00 meter per second, multiplied with time is 0.747. Time remains the same, and that will be equals to 4.48 meter. So this distance is 4.48 meter. Extra horizontal distance traveled will be this, which will be 4.48 minus 4.10, which is equals to 0.38 meter. So it travels this much more distance when the horizontal speed is increased, but the time remains the same. Now if you compare it with the initial question that I asked, There also the time the ball took to reach the ground is same, but one ball traveled some distance in the horizontal direction and other doesn't. So we can compare it from that example also. Now next I'll be giving one practice question to you, and the question is this. It says that if the height h is increased, if this height h is increased and this distance t, this width remains the same, then does the minimum speed needed to cross the crevasse increase, decrease, or stays the same? This is the question, and you have to write the answer in the comment box below. And if you find any confusion, I'll give the answer separately. So this is all with this video, and in the next video we'll discuss general launch angle.